We learned altogether 6 procedures for testing statistical claims about 3 different pairs of parameters. So how do we know when and which procedure to use? Next, I will summarize all the procedures for testing hypotheses for 2 parameters. First, we must determine the statistical claim that is being tested in 2 steps. Look for the keywords to identify the parameters in the claim. A pair of means or averages when testing a claim about 2 population means. A pair of proportions or percentages when testing a claim about 2 population proportions. Or a pair of variances or standard deviations when testing a claim about 2 population variances. Next, look for the keywords that identify the inequality in the claim, such as less than, or greater than, or not equal. Based on the inequality in the claim, we classify the test as left tail, two tail, or right tail. A statistical claim in the form of an inequality is called the alternative hypothesis, and a statistical claim in the form of an equation is called the null hypothesis. Next, we determine the procedure in the following way. Always use F procedure for testing claims about 2 variances. The Z procedure for testing claims about 2 proportions. When testing claims about 2 means, we first need to check whether the samples are paired or not. If they are paired, then use 2-paired t-test. If they are independent, then we check whether the population standard deviations are known. If the population standard deviations are known, then we use the Z procedure. If the population standard deviations are unknown, then we check whether they can be assumed equal. If unknown population standard deviations can be assumed equal, then we use T-pooled procedure. Otherwise, T-non-pooled procedure. Remember, before applying the procedure, we have to verify all the assumptions. So before starting the procedure, we must have already figured out the significance level alpha, which is the maximum tolerated type 1 error. The most common values for alpha are 1, 5, and 10%. In the next step, we compute the test statistic using a formula that is specific to each procedure. Note that we label the test statistic using the lowercase letter of the name of the involved distribution with the index 0. That is, in a z-test, the test statistic is called z0. In the t-test, the test statistic is called t0. And in the f-test, the test statistic is called f0. To apply the formula, one must be able to understand the notation. In this step, it may be necessary to reread the question several times to extract the information. Next, we can use critical value approach. In this approach, we construct the rejection region under the probability density curve of the involved distribution, based on the type of the test and the significance level alpha. The boundaries of the region are called the critical values and can be found in a similar way for all procedures. We reject the null hypothesis if the test statistic is in the rejection region. Alternatively, we can use the p-value approach. In this approach, we find the p-value depending on the test statistic and the type of the test. We reject the null hypothesis if the p-value is less than the significance level alpha. Due to the logic of a hypothesis testing procedure, there are only 2 outcomes of the procedure: reject or not reject the null hypothesis. The double negative in this case is never interpreted as a positive. That is, we never accept the null hypothesis. Therefore, the interpretation is that we either do or do not have sufficient evidence to suggest the alternative hypothesis. All 6 procedures can be summarized in the following table. It is easy to see that the procedures not only have a lot in common among themselves, but also with the procedures for testing the hypothesis about one population parameter. Note that this table doesn't contain the formulas for computing the pooled standard deviation and the degrees of freedom in a non-pooled t procedure, only due to their large size. I just summarized all 6 procedures for testing statistical claims about 2 population parameters.